Hi, Mr. End here, and today we're looking at parent graphs. And the graphing is done by Desmos.com. I suggest you look it up, check it out. It's a great program just to learn graphing. Now here, off to the left-hand side, we have the function f of x equals, in this case, x. And below that, we have a table of x values and corresponding function output values. So here for f of x, this is your classic linear function. This is your classic line. So here, y equals x is another way of thinking about it. So if you input 0, you get 0 out. Input 1, you get 1. 2, 2. Negative 1, negative 1. Negative 2, negative 2. It's your input equals your output. So this is the classic linear line. Here we go. And now if we go past this, if we now do absolute value of x, we now have a new type of line. Now instead of negative 1 being negative 1, the absolute value of negative 1 becomes positive. So it's positive 1. The absolute value of negative 2 becomes positive 2. So what was down in this left region now gets reflected up above the x-axis. Okay? And this is the absolute value of x. So you have 1, 1, 2, 2. Then you have negative 1, 1. Negative 1, or negative 2, 2. Okay? So now let's move into more powers. Let's look at some powers and how they affect things. So x squared here, and we have this classic x squared, this classic parabola. So 0, 0, because 0 squared is 0. 1 squared is 1. However, 2 squared is 4. And then not shown in the graph, 3 squared would be 9. So here we have 0, 0, 1, 1, and then 2, 4. And then it's symmetrical about the y-axis is another thing to note here. Of course, we'll go further into quadratics, which is a keyword for this, when we come to that. But for right now, we're just taking a general overview of these. Okay. Now let's look how things happen when we manipulate the power. So let's make it x cubed. So now x cubed, the interesting thing about an x cubed is that you can have negatives come out. So you can have 0, 0, of course, but you can have negative 1, and the cube of negative 1 is negative 1. And 1 is, the cube of 1 is 1. The cube of 2 is 8, so it curves much quicker than the x squared. But still, this x cubed is going to tend to look with this curved feature, but then it goes in negatively as it goes off, as you go to the left of 0. So it goes down into the negatives. Now the last two are going to be basically inverses of the last two we did. So square root of x. Well, this corresponds kind of to an x squared. This is going off to the right, where x squared is going up. But now we have this kind of swoop off to the left, and it grows much slower. The square root does not grow very quickly. So here we have 0, 0, 1, 1, but then 2 is this 1.41. It's the square root of 2. You'd need to go to 4 next to get a whole number, and that would be 2. Square root of 4 is 2. So it does not grow very quickly. It just goes off to the right. And the last function we're looking at is the cube root of x. So the cube root is found under here. We'll put a 3 in the index. Cube root of x. So here's the cube root of x, and it's kind of like a sideways cube. Okay? So then you have the swooping motion off to the right, and then you have one dipping down off to the left in the negative area. Negative region of the graph. Okay? And this is just the cube root of x. So here you have 0, 0, and you have 1, 1. But the next whole number you get to isn't all the way out till 8. So sometimes people don't graph all that far out, but the cube root of 8 is 2. So that's the next one you're looking at. These are the general graphs you'll be dealing with at first in college algebra, and then we'll just be using graph transformations to shift and move them and twist them around. And that's what we're going to be dealing with in this chapter. If you have any questions, don't hesitate